Primary key versus foreign key explained. Welcome back, everyone. Today we're covering one of the most essential concepts in the world of databases, primary keys and foreign keys. Whether you're a beginner or brushing up for an interview, by the end of this video, these two concepts will make complete sense. Let's dive in. The invisible glue of the Internet. Every database you interact with daily, your bank account, your streaming service, your social media feed, all of them rely on two core things to stay connected, organized, and accurate. Those two things are the primary key and foreign key. They are, quite literally, the invisible glue holding data together. What is a primary key? A primary key is a column that uniquely identifies every single row in a database table. Think of it like a national ID card. No two people share the same ID number. It never changes, it's never left blank. It simply says, this specific record and no other is this one. The three rules of a primary key. A primary key must follow three non-negotiable rules. First, unique. No two rows can ever share the same value. Second, not null. It can never be empty, not even once. Third, stable. It should never change over time. Break any one of these rules, and it stops being a valid primary key. The primary key in the real world. Here's a students table with student IDs 101, 102, and 103. Now imagine two students both named James enroll in the same school. How does the database tell them apart? Simple, by their student ID. The name might repeat, but the primary key never does. That's exactly why it exists.
Types of primary keys. There are two types of primary keys. A natural key is a value that already exists in the real world and is naturally unique, like a passport number or a national ID. A surrogate key is an artificial ID created purely for the database, like an auto-incremented number. Surrogate keys are the most common and reliable choice. What is a foreign key? A foreign key is a column in one table that points directly to the primary key of another table. It is the bridge that connects two separate tables into a relationship. Without foreign keys, your database would just be a collection of isolated, disconnected tables, and that's exactly what makes it not relational. The golden rule, referential integrity. Here is the most important rule of foreign keys. A foreign key value must either match an existing primary key in the reference table or be null. That's it. You simply cannot link a record to something that doesn't exist. No ghost entries, no broken links, no orphaned records, ever. This protection is called referential integrity. The foreign key in the real world. Look at these two tables, students and enrollments. The student ID in the enrollments table is a foreign key pointing back to the students table. Notice that student ID 101, James, appears twice in enrollments. That's perfectly fine. Foreign keys can repeat. But that ID must exist in the students table first. No exceptions. Primary key versus foreign key. Now let's place them side by side for a clean, direct comparison. These two keys work differently, live in different places, and serve completely different purposes, but they work together to make a relational database function. Let's go through each difference one by one so the contrast is completely clear.
The ultimate cheat sheet, part 1. Three key differences right here. Purpose. The primary key uniquely identifies rows. The foreign key links two tables together. Uniqueness. Primary keys are always unique. Foreign keys can repeat freely. Null values. A primary key can never be null, while a foreign key can sometimes be null when a relationship is optional. The ultimate cheat sheet, part 2. Two more critical differences. Count per table. A table can only have one primary key, but it can have many foreign keys pointing to different tables. Location. A primary key lives in its own table, while a foreign key lives in the child table, but references the parent. Primary key enforces entity integrity. Foreign key enforces referential integrity. Why they matter. The online store. Here's where it all comes together. An online store has three tables: customers, products, and orders. The orders table holds a customer ID and a product ID, both foreign keys. They link back to their respective parent tables. This is how one order record knows who bought what. That's a relational database working exactly as designed. Blocking the ghost customer. What happens if someone tries to insert an order using customer ID 999, a customer that simply doesn't exist in the customer's table? The database blocks it immediately. No corrupted records, no broken data, no phantom entries slipping through. The foreign key acts as a security guard, and it never lets a ghost customer through the door. The golden rule to remember. And here's the simplest way to lock all of this in your memory forever. The primary key says, "This is who I am." The foreign key says, "This is who I'm connected to." 2 keys, 2 jobs, 1 powerful system. That's the foundation every relational database in the world is built on.